Hey, algebra students, we're going to take a look at systems of equations word problem notes. And for this video, I'm going to take you through a few of the problems or several of the problems, and then I'm going to ask you to continue on your own. So taking a look at number one, we have the sum of two numbers is equal to 95, and their difference is 15. Now, we have solved these problems before. We just did them by defining one variable. And again, that method might be very comfortable for you, and that's good. We would want to work on solving with the system. So we do want to establish two variables here. And then, of course, later on, you'll have a choice of methods. So the sum of two numbers is equal to 95. So we're just going to define our variables, and I'm just going to say x is my first number. And, of course, you can use any letter you want. Y is my second number. And so to establish that the sum of those numbers is 95, that would give me the equation x plus y is equal to 95. And their difference is 15, difference being subtraction, difference is 15. Now, it doesn't matter what order you put their difference in there. It just establishes that for me, my x is going to be my larger value. And then we can solve by substitution or elimination. I'm not going to graph at this point, but substitution or elimination. And in this equation, you can see that elimination is probably the fastest route because those are ready to eliminate. So I'm going to get 2x is equal to 110, divide by 2, and I find that my x is equal to 55. Now I do have to plug that back in to find the other value. And I can plug it into either equation. And so I get that y is equal to 40. Of course, I would want to check that in both equations to make sure it works. And because I have a word problem, I should give a word answer. So again, for the next word problem, we've got two unknowns here. Hot dogs cost $1.50 and sodas cost $4.25. If the Hazel family bought a total of 13 items for a cost of $33.25, how many of each item did the Hazels buy? And so I'm going to establish my two unknowns. So I'm going to say x is equal to the number of hot dogs and that makes y my number of sodas. And so I want to write two equations based on the information that I have. And if I'm looking at cost, then I have $1.50 for the number of hot dogs plus $4.25 for each soda, and that is equal to the total that they spent, which is $33.25. And then when I'm looking at just the number being 13 items, that means the sum of my items is 13. Now, this set of equations would be a little awkward to do elimination with because, you know, what am I going to multiply by? That just gets a little weird. So for this, I am going to solve for one of the variables, and I'm going to use substitution and substitute that value in for y in the first equation. So I'm going to take that y value and plug it in. And so that's going to be that 425 times the whole quantity of y. And that's equal to the 3325 total. So distributing that 425 through that, and then I want to combine my like terms. That gives me a negative 2.75x is equal to a negative 22, and then dividing. Which gives me x as 8. Then I want to plug that back in, and I want to plug that back into my other equation, and so I get 8 plus y is equal to 13. Of course, then that's going to give me y is equal to 5. So they bought 5 hot dogs. I'm sorry, they bought 8 hot dogs. And 5 sodas. So for the next equation, we have Eric is 8 years older than his brother, and the sum of the brothers' ages is 48. Find the age of each brother. So our two unknowns are our ages of the brothers. So I'm just going to make x is equal to Eric's age, and y is equal to the brother's age. And looking at each sentence as its own equation. So Eric is, and that's 8 years older than his brother. And so that's x equals 8 plus y, just doing that phrase by phrase. And then the sum of their ages is 48, would be x plus y is equal to 48. Again, you can use elimination or substitution. This one is nicely set up for substitution already. So that's what I'm going to choose, but you could rearrange and do elimination if you prefer. If I substitute in 8 plus y for x, I get 8 plus y is equal to 48. And so that gives me 8 plus 2y is equal to 48, which means 2y is equal to 40, and y is equal to 20. And if I plug that back in, then I get to one of the equations. So I would get x is equal to 8 plus 20, and so x is equal to 28. And so I can conclude that Eric is 28, and his brother is 20. All right, so let's continue with problem number 4. The perimeter of the rectangle is 36 feet. The length is 4 more than 3 times the width. So what are the dimensions of the rectangle? So my two unknowns are length and width. So L is going to be my length, and W is my width. And the first equation, perimeter, I need to think about the perimeter formula of a rectangle. So the perimeter is 36, so that's equal to 2 times the length plus 2 times the width. Then the second equation is that the length is, so that's L equals 4 more than, which is 4 plus, 3 times the width, so that's 3W. And again, you can solve with any method, but this is nicely set up for substitution. So I'm going to rewrite that first equation, but instead of L, I'm going to put 4 plus 3W in place of L, substituting that in. Then I solve that equation. edit there. And we get that the width is 3.5 feet, and we'd want to plug that back in to one of the equations here, or to that next equation. So I get 4 plus 3 times that 3.5, and that gives me a length of 14.5 feet. So hopefully you get the idea. It's the same as kind of solving them with one variable, just using the two variable method and the systems substitution or elimination methods that we've now are kind of practicing. So I'd love for you to go through the packet and see how many you can get through and get right, and we will check those in class.